Welcome to the practice test of Chapter 7. I'm going to write that down here so you can find it. In this practice test, I'm going to break it up. I'm not going to do all of it in this one video because it'll be too long. And then you can just go to the problems that you didn't get. So we're going to do, in this video, I'm going to do problems 1 through 3. So you're going to watch. I do give hints for the next test in this review. So hopefully you did the practice test, so you're not just watching this, and you can just check to see the ones you didn't get, how to get them. So the first one is algebra review. And this is tough for some of you who didn't have me for algebra or didn't have the greatest algebra, if you did it on your own or whatever. But I'm going to try to explain it here. These are square roots. So what this is the directions say do is indicated. Write it in a simple radical form. So this isn't simplified. It's kind of like if you had the fraction 2/4 and you just left it there. That wouldn't be that's not the completed answer. You have to reduce it to 1/2. Well, these radicals are not completely simplified. So what we have to do is simplify it. And to do that, we find the biggest square root that we can find that goes into whatever square root we have. So let's write down perfect squares. It's the biggest perfect square that goes into it. So our perfect squares would be 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. That's all the further we need for these problems. So in order to simplify it, kind of like you say, what is the biggest number that goes into 2 and 4? Well, we're going to say what's the biggest perfect square that goes into 99. So 4 doesn't go into 99, 9 goes into 99, and you have to check the other ones. None of these go into 99. So we break it into the biggest perfect square that goes into 99, and then what's left when we divide it. So 99 divided by 9 is 11. Then we can simplify. The square root of 99 is 3. Square root of 11, we can't simplify it anymore because there's no perfect squares that go into it, so this is our final answer. Go on to B. B is the square root of 72 plus the square root of 2. This one's totally simplified. There's nothing that will divide. No, there aren't any perfect squares that divide into 2. So let's go over here. So we say into it. So we could be tempted to stop, but we might not simplify it the whole way if we do that. 16 doesn't go into it. 25 doesn't go into it. Then we find that 36 does in fact divide into 72. So we're going to separate it into the square root of 36 times the square root of 2 plus the square root of 2. We can keep working on this side. Square root of 36 is 6. Square root of 2 plus the square root of 2. Now we can add these two radicals together. It's kind of like having 6x plus x. These are the same, so you can add the coefficients. These are the same, so we can add the coefficients. So it'll be 6, and there's a 1 here even though it's not there, so you get 7 square root of 2. And the final one that we have on this sheet is the square root of 17 squared plus 15 squared. In this one, you have to do what's under the radical first. You can't just take the square root of 17 and the square root of 15. You can't do that. So we're going to take the square root of 17, which is 289, plus, not the square root, 17 squared. 15 squared is 225. They're both still under the radical. That's going to give us a square root of 60. Is that a minus? That should have been a minus sign. Let's get my little eraser here. This one right here should have been a minus sign. Whoops, I gotta erase this one too. Now it makes sense. So we get minus, and we're going to get the square root of 36, and that gives you 6. Now on the test, they give you one that's a little different. They have something like this, 2 square root of 5 squared. This is different than the previous one because they're connected by multiplication. So what we can do when they're connected by multiplication is we have 2 squared, and we have the square root of 5 squared. And that's going to give us 4 times 5, which is 20. Square root of 5 times the square root of 5, that would be square root of 5 squared, is equal to square root of 25, which equals 5. So whenever you square a square root, you just get the number under the radical. So that was a very quick review. I didn't go in exactly how you do these. So if you didn't have these before, I take that into consideration. But if you had me last year, these should all be correct. All right, let's go up to problem number 2. It's a definition. Copy and complete the following. A trapezoid is an isosceles if both legs are equal. Now, just keep in mind the one that's going to be on the test is not that one. The one on the test will have something to do with rhombuses. So make sure you know the definition of rhombuses. Oops. Definition of rhombuses. That's a hint. Big hint. All right, on to the true and false. Our nightmares, and the nightmares continue. You have to know your definitions inside and outside. That's all I can say about these. First one says, if one pair of opposite sides of the quadrilateral are equal in parallel, the quadrilateral must be a parallelogram. So we have a theorem that says if one side is equal in parallel, then it's going to be a parallelogram. If you think about it, we have sides that are equal. This is going to be really bad. I can't even use a ruler. And they're parallel. So just picture that. If they're equal and parallel, then these lines have to be the same because the distance between them are going to be the same. So this one's a big fat true. If they're equal and parallel, it's going to be a parallelogram. Next one. All 4 angles of a quadrilateral may be acute. Well, quadrilateral means it has 4 sides. I'll try not to make this any sort of quadrilateral that we know. Here's just some random quadrilateral. It means it has 4 sides. We know that all 4 sides of a quadrilateral, 1, 2, all 4 angles, 3, 4, 1 plus 2 plus 3 plus 4 have to equal 360. Well, if they're all acute, acute means less than 90, then we know that if these were all less than 90, then when you add them all up, even if they're each 89, they're going to be less than 360. So that one's a big fat false. I think it's helpful to draw pictures when you do these true and false ones because they are so tricky. Those two weren't very hard though. C. All 4 angles, if diagonals of a quadrilateral are perpendicular, the quadrilateral is a rhombus. What is a rhombus? A rhombus, all 4 sides are equal, but it's the angles are not 90 on a rhombus. Of course, a square is a rhombus. And I have a question on this one myself. So this is a right angle. That is true of a rhombus, but it could also be a square, so that one's false. I'm going to be lenient on the true and false ones in this one because I think a square is a rhombus, and so this one was really tricky. But this one's false. I think the reason is if the diagonals of a quadrilateral or perpendicular quadrilateral is a rhombus, it could be a square as well. That's why that one is very tricky. Okay, the next one says, if the diagonals of a quadrilateral, all squares are rectangles. So let's draw a square, and let's see if we know our definitions of a rectangle. If you look on the help board, I have everything mapped out for you. All squares are rectangles. Well, what is a rectangle? A rectangle has 4 right angles. The opposite sides are equal. Is that true of a square? Yes, it's true of a square. Therefore, a square is a rectangle, so it's a big fat true. And E. The base angles of a trapezoid may be supplementary. The answer to this one is false, and I am not exactly sure why. I found several things wrong in these answers, so I just figured this one says the base angles of a trapezoid may be supplementary. I think it's true. Let me try to show you. If you have the base angle, say this one, here's the base angle. This is going to be our parallel side. if we have this base angle is 90, that would mean the other base angle would have to be 90, would have to be 90. So that one wouldn't work. That one doesn't work. That's not good. Let's try another one. Let's draw our top angle. Let's do 110. Let's make one of these 110. I'll just do this one, 110. And we'll make the other one 70. It's a little less than 90. 70. And then you have this, whatever this side ends up. These two angles are supplementary, but the sides are not, the sides don't have to be equal. We'll just get rid of that. Let's draw our side longer. There, the sides aren't equal. So it is parallel. If it's parallel, then maybe the sides do end up being equal. But I don't think so. If these are parallel, yeah, so I guess this one is false. I don't think there's any way you can do this one. So this will be false. And I told you I'm going to be a little bit lenient on these because I think some of these we haven't explained well enough. So this one's false. There's no way you can do that one that I can see. If you see that you can, could you please put on the help board? So these are the answers to those. I think these true and false ones are more questionable than they've been in the past, so I'll try to help you out on this. Now on the test, some hints. Let me look at the actual test here. Let's see, I would know everything about diagonals of rhombuses. Do they bisect each other or not? Know about diagonals of a quadrilateral equal. Know everything about diagonals. I think that would be really helpful to know which diagonals are equal, which diagonals bisect each other. That's about all the hints that I can give you for a test, the real test. So these are the first three. If you have any questions on these before you take your test, put it on the help board. I won't be home till tomorrow till about 10 in the morning to answer your questions, but have your questions answered before you take your test. So that's it for the questions 1 through 3.